Most of the time you spend in CAM should be spent building toolpath. With EDGECAM it can be. Let's have a look at how EDGECAM's virtual CAM setup technology speeds up the process for turning applications. This is a finished EDGECAM part. It contains all toolpath, both turning and live tool milling, for a machining setup in a single spindle, single turret turning center. It took approximately 20 minutes to get to this point using out-of-the-box software. That's a reasonable expectation for the trained and experienced EDGECAM user working with a properly implemented CAM software. Let's look at machining simulation, where we can see how this setup works. Notice that the part begins as a blank of material. We can see the CNC machine and all tools in the turret. Everything in here is collision checked, and we can see the machining simulation and how the material is removed from the part. We have ability to cut away the inside detail, which can be helpful for seeing tools such as our drills and boring bars and ensuring that our process comes together correctly and without problems as we intended. We'll speed up the simulation a bit past the waveform roughing and threading and finishing. We see here some milling of some flats with a live tool, then some radial holes, and then the part off. That's exactly what we expected and intended as we built the tool path, so we're ready to generate G-code. The edit-free G-code can immediately be sent to our CNC machine. Let's now rewind the process and look at how this all began at the virtual CAM setup. We'll begin the process with a brand new file, loading a solid and seeing how quickly the virtual CAM setup can be created. EDGECAM immediately orients the part, and since this orientation is suitable, we'll continue with adding stock to the workpiece. We'll select a length that's long enough for at least a couple of part cycles, and then put in our key stock parameters. Stock is instantly created, and we can now move to adding an optional work holding fixture. I'm going to add this royal collet, and looking at what EDGECAM already knows about the part and seeing our part length, we'll choose a suitable stock length for this machining setup, which will include a part off operation. Then let's go and connect this to a CNC machine. This would represent the machine tools you have available in your machine shop, so we'll choose a suitable machine tool and a tooling package. Determine where 0 should be. And we can see that the virtual CAM setup is immediately created. Now at this stage I would like to align this flat to our 0 degree position. That's easily done by choosing that flat, and whatever angle that needs to be rotated at, the part is oriented to that. We can now find machinable features on the part. We'll ask for front features only on this setup, and from a mill perspective we don't need any pockets or bosses, and we'll find holes that are visible from that side as well as radial holes. EDGECAM finds all of the features needed, and we're at this point ready to go to machining and begin the CAM process. Notice how quickly that was done. Just about 1 minute. Let's now go back and rewind and have a look at the individual stages of the virtual CAM setup over on the Setup tab that make this so quick to put together. Let's turn off the timer, and then we'll go and into our Preferences command, File and Preferences. I'm going to go to the Solids tab and turn off the workflow alignment options. Normally these are something we want on, and they are part of my secret weapon for the fast virtual CAM setup. But let's turn them off and see what happens when we load that same solid model in. I'll give you a clue. This time the model's going to come in loaded at the orientation that the CAD designer built it in, which likely isn't the same orientation we'll need for machining. We can see that here, and when we go to a horizontal turn view, we would be expecting that the part is lined up with the center line parallel to the blue z-axis. And we can see it's not, it's out of position, and we're going to need to change that. Well, EDGECAM can certainly do that, and it's actually very easy to do with the align component command. We can pick a cylindrical face, the part centered up. We can flip it the other direction if needed, choose a face to be the Z0 position, and even a face for a C-axis orientation. So that was very easy to do, but let's go back and look at what happens when workflow alignment options are allowed to do their job. And they're going to speed this up quite a bit because it gives EDGECAM permission to reorient the solid when it's loaded in, and it will detect it's a turn part because it's mostly round, and it will bring the part into a suitable orientation that we can quickly adjust if needed. And sometimes this orientation will even be exactly what we want. When I choose the turn view, I can see the parts oriented exactly as I want. And sometimes this is going to happen. If it did not, we could go to the setup window and use the technology here, choose a material for feed and speed lookup, and quickly orient the part if we need to. Notice that we start with part information where EDGECAM already reminds us of the information it's collected from the part, in this case the part size. Now here when I go to flip the part, notice that not only is the part flipped, but that the orientation with Z0 at the front of the part stays intact, which is really neat. We also have the ability to pick a C-axis orientation right here and change the rotation angle of the part simply based on some part feature. The part can be further moved as needed, and our datum area allows us to set the datum at either the front or back of the part. There is an option to set that based on stock, and that's grayed out at the moment because I haven't added stock to the part yet. Let's go and do that. And out of the different options, we'll use the fit stock command. We can see that the information that EDGECAM already knows about the solid is used to assist us in quickly creating a stock blank. So I can put in the length of blank, how much I want at the front end of my part, and how much we want for part diameter. I tend to use a blank when we're doing part off that's at least a couple part cycles longer than the part. And notice that we can also choose the units that we want to use for the dimensions we're plugging in. EDGECAM is dual unit capable, equally at home in inches and in millimeters. When we render the stock, we can see the stock volume and the part inside it. This is coming along as we expect. If the stock size ever changes in the future, the fit stock command can be used to replace the current stock with a fresh and different stock. The option of the fixture database is available as well, and this represents standard work holding fixtures that are in our company that we've added to the tool store database. I can choose that same collet chuck that we showed earlier. EDGECAM reminds us of the part information through the setup window at any time, and we can put in the intended part stick out and see the preview of how that's going to look. And once there's something suitable and the fixture's added, now I can move on to connect this to the CNC machine. When we create the sequence, we see the list of our company's post processors for our company's CNC machines. I'll choose a CNC machine and even an optional toolkit, which can really streamline the tool selection process. The existing information in the CAM model is already preserved in the setup, and we can then select the datum or work system 0 we want to use. This post processor has graphics, and EDGECAM previews those for us, and we can immediately move to find features to automatically find common machinable geometric regions in the part. Most trained users will be familiar with feature recognition and find that it's a very fast process on a part like this. Everything looks good here. Instead of creating toolpath at this point, I do want to stop and show associativity. At any time, we can take the model we've been using and replace it with a different model. In this case, a design change. So as I reload the updated part, we can see that the orientation work that we've done in our virtual CAM setup is retained and features are updated automatically exactly as we'd expect from EDGECAM. Let's continue on and look at some other examples where we'll show some different variations of other types of stock that can be added to parts in addition to the fit stock command. This next part is a fitting, and this fitting has a hex shape on the OD. We are going to machine this using hex stock rather than cylindrical stock. So first we'll select the material and then go to the stock database. Now there is a valid stock, but there's also several that are not valid. They are the brass material, but their stock sizes are too small for this part. EDGECAM automatically detects that and steers us towards suitable stock. We'll add the stock. We'll specify how much sticks off the front side of the part for face-off, and the stock is immediately put in and aligned with the part. Very simple, very easy. The stock database is intended to capture common stock sizes that you may keep on the shelf, so to speak. And the way that that's plugged in is working off Launcher, going to the Applications in the Managers group. We see the Stock Manager. Now we already saw the results of using what is in the Fixture Manager to add the collet chuck in a previous example. This time we'll open up the Stock Manager and notice there's a variety of materials in here. We can create additional materials that represent the materials that your company keeps on the shelf if you do that. They could be cylindrical, tubular, rectangular shaped, hex shaped like we saw here, or even custom shapes, which might represent common castings or forgings. Once the material is in the Stock Manager, it can easily be inserted from the stock database inside EDGECAM. This is stored as part of the central tool store database. Next, I'm going to go look at a part with some slightly more complex stock. We'll begin with opening a solid model. And this model is a wheel hub, and it is intended to be a cast part. Let's begin first by going in and changing the part orientation. So I'll flip the part, and that looks great. But when we look in toward the chucking system, we can see the C-axis orientation does not line up to one of our holes. Easily solved. We'll simply pick C orientation, choose the feature, and whatever rotation is needed, EDGECAM takes care of that. The orientation of the part is now correct. And so now I'm going to go to the Insert Stock command and add in a casting model. This is a solid model. We created this using Designer, but quite frankly, it can come from any solid modeler or even be an STL file. Once that's inserted in, we can see the orientation of that, and it exactly matches our part. EDGECAM, it does an awesome job with this command of aligning the stock model to exactly the same orientation as the component you're working with. If you need to reorient it further, you can, but in most cases it lands exactly the way that you need it. So let's look at what goes into the virtual CAM setup. First of all, that includes the component, which is the finished part. In this case, we're talking about solid models, and when a solid model is loaded, EDGECAM offers the setup window. The technology in this window assists with correctly orienting the part and assigning the work datum. That's very easily done, and then we can move on to the commands on the Setup tab to add stock to the part, work holding, which is optional, and connect this to the CNC machine. The point is that EDGECAM's virtual CAM setup is both fast and flexible. Our interface technology allows users to quickly create the CAM setup for turning, find machinable features, and move directly to building toolpath. This is all done using out-of-the-box software capability. Hexagon technology and expertise is helping our customers improve manufacturing processes and improve product quality. We invite you to bring us your machining challenges.